Namaste. Myself, Mr. Birajdar Balasaheb, Assistant Professor, Department of Humanities and Science, Walchand Institute of Technology, Solapur. In this video lecture, we will discuss linear differential equation of higher order with constant coefficients. Learning outcome. At the end of this session, students will be able to solve higher order linear differential equation f of d into y equal to x of x when x of x not equal to 0 using general method. Now let us start with general method to find particular integral. In a linear differential equation f of d into y equal to x of x, if the function x of x is not in any of the standard forms discussed in shortcut method, then pi is obtained using general method. General method requires following three results along with procedure of partial fraction. The first result is meaning of 1 upon d minus m operated on x of x is e to power m into x into integration e raised to minus mx x of x dx. The second result is 1 upon d plus m operated on x of x means e to power minus mx into integration e to power mx into function x of x dx. And third result is 1 upon d operated on x of x means integration of function x of x with respect to x. Now let us pause the video for a while and write answer to the question. Question is simplify 1 upon f of d operated on tan x. Come back, I hope you return answer to this. Solution is, as we know that 1 upon d operated on x of x means integration of function x of x dx. Therefore, 1 by d operated on tan x means integration of tan x. But integration of tan x is log of sec x. Therefore, 1 by d operated on tan x is equal to log of sec x. Now let us consider example. Solve the differential equation d square minus 3d plus 2 into y is equal to sine of e to power minus x. Solution. Here f of d equal to d square minus 3d plus 2 and x of x equal to sine of e raised to minus x. Now first of all we find complementary function. Here auxiliary equation is d square minus 3d plus 2 equal to 0. Solve it for d. Now factors of left hand side d minus 2 into d minus 1 equal to 0. Equating each factor equal to 0, we get d equal to 2 and d equal to 1. So these two roots are real and distinct. Hence by first case of complementary function, CF equal to C1 into e to power 2x plus C2 into e to power 1x. Now for Pi, formula is Pi equal to 1 upon f of d operated on x of x. Now substitute the value of f of d and x of x. We get Pi equal to 1 upon d square minus 3d plus 2 operated on sine of e raised to minus x. Now here function sine of e raised to minus x, it does not partially or completely belongs to any one of the standard function discussed in the shortcut method. Therefore, here shortcut method fails. Hence, we have to use general method to simplify right hand side. In order to use general method, first we have to find partial fractions of the rational function 1 upon d square minus 3d plus 2. Therefore, by partial fraction 1 upon d square minus 3d plus 2, which is equal to 1 upon d minus 2 into d minus 1, can be written as a upon d minus 2 plus b upon d minus 1. Denote this equation by 1. Now we have to determine a and b. For that, 1 upon d minus 2 into d minus 1 equal to, in the right hand side, take LCM d minus 2 into d minus 1, and now in numerator cross multiplication we get a into d minus 1 plus b into d minus 2. Now from both these sides denominator gets cancelled. We get 1 equal to a into bracket d minus 1 plus b into bracket d minus 2. Denote this by equation number 2. Now to find value of a and b, we choose proper value of d. Suppose d minus 2 equal to 0, that means d equal to 2. Put in equation number 2. We get 1 equal to a into bracket 2 minus 1 plus b into bracket 2 minus 2, it is 0. Therefore, we get a equal to 1. Now, suppose d minus 1 equal to 0, that gives d equal to 1. Put in equation number 2. We get 1 equal to a into bracket 1 minus 1, it is 0, plus b into bracket 1 minus 2, which gives value of b equal to minus 1. Hence, from equation number 1, the partial fraction of 1 upon d square minus 3d plus 2 equal to 1 upon d minus 2 because a is 1, then minus 1 upon d minus 1 because b is minus 1. Therefore, pi equal to actually 1 upon d square minus 3d plus 2 operated on sine of e raised to minus x. It can be written as pi equal to 1 by d minus 2 minus 1 upon d minus 1 operated on sine of e raised to minus x. Now multiply this function inside. We get pi equal to 1 upon d minus 2 operated on sine of e raised to minus x, then minus 1 upon d minus 1 operated on sine of e raised to minus x. This is can be written as, using formula 1 upon d minus m operated on x of x is equal to e raised to mx into integration e raised to minus mx into x of x function into dx. With the help of this formula, we can write pi equal to the first term, in that m is 2. Therefore, e raised to 2x into integration e raised to minus 2x into sine of e raised to minus x dx. Then minus, in the second term, m is 1. So that e raised to 1x, that is e raised to x, into integration e raised to minus x and into sine of e raised to minus x dx. Therefore, we can rewrite pi equal to e raised to 2x into integration e raised to minus 2x, you can write e raised to minus x into e raised to minus x into sine of e raised to minus x into dx. Then minus e raised to x into integration e raised to minus x sine of e raised to minus x dx. Now, in order to integrate these two integrals, we have to use substitution method. Here, substitute e raised to minus x equal to t, then derivative of e raised to minus x is minus e raised to minus x into dx. Multiply minus sign on both the side. We get e raised to minus x dx equal to minus dt. Substitute these two in these two integrals. We get pi equal to e raised to 2x as it is into integration t sin t and into minus dt. Then minus e raised to x as it is into integration sine of t into minus dt. Therefore, pi equal to minus e raised to 2x into integration t sin t dt, then minus minus plus e raised to x into integration sin t dt. Therefore, pi equal to minus e raised to 2x into bracket. Now, by integration by parts, the integration of t sin t can be written as t into integration of sin t is minus cos t, then minus integration derivative of t is 1 and into integration of sin t is minus cos t dt bracket close, then plus e to power x as it is and integration of sin t is minus cos t. Therefore, pi equal to minus e raised to 2x as it is and in bracket minus t cos t, then minus minus plus integration of cos t is sin t bracket close, then minus e raised to x cos t. Now substitute t equal to e raised to minus x. We get pi equal to minus e raised to 2x in bracket minus e raised to minus x into cos of e raised to minus x plus sin of e raised to minus x bracket close, then minus e to power x into cos of e raised to minus x. Therefore, Pi equal to, when we multiply minus e raised to 2x inside in first term, we get e raised to x into cos of e raised to minus x, then minus plus minus e raised to 2x into sin of e raised to minus x, then minus e raised to x cos of e raised to minus x. Now e raised to x cos of e raised to minus x gets cancelled with minus e raised to x cos of e raised to minus x. Therefore, Pi equal to minus e to power 2x sin of e raised to minus x. Hence, the general solution of the given equation is dependent variable y equal to Cf plus Pi. In this, substitute the value of Cf and Pi, we get y equal to C1 e raised to 2x plus C2 e raised to x, this is the Cf, and plus Pi is minus e to power 2x sin of e raised to minus x. This is the required solution of Q1 differential equation. To prepare this video lecture, I refer this book as a reference. Thank you.